When we are working directly with the database, that is physical data present in the database, there is if any changes made by the client that will affect the complete database. Any changes made in the physical level that should not affect on the logical level. Any changes made in the logical level should not affect on the external level. Interface is that is how the database provide the interaction between each other. Hello everybody, welcome back to the session of Dbms. Myself Induje, faculty in the Department of Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Today we are going to discuss about architecture of database. Okay, database management system architecture. Database management system architecture. What is database? We have already discussed in so many sessions. Now we are going to discuss what is database management system, how we are going to design a system for managing all the types of data so far what we have gone through with. So database management system designs depends upon its architecture. So when you are constructing any system, architecture is a fundamental for that. You have to have an architecture to design any system. Not only the database system, any system you should have a basic architecture. Now we are going to see how many different types of architecture we have in the database management systems. The basic what we are using is a client-server architecture. What do you mean by client-server architecture? Client is the one who is requesting for the data. Server is the one who is having the data and giving whenever the client is requesting. That is called as request and response. Request and response type of architecture is called as client-server architecture. Basically deals with a large number of the pieces. The client may be in many numbers, web servers, database servers and other components that are connected with the network. When we have to give the request or the database has to respond, we should have some connection between the client and then the server. So that connection is called as network. When the client server architecture we can use, when we have a network connection, we can use a client server architecture. The client server architecture consists of many pieces and the workstation which are connected via network. Database management system architecture depends on how the users are connected to the database to get their request done. How they are connected to request, you should have some connection. For example, as a student, you can ask any question related to the particular subject or related to computer science to me because I have a relationship between you. There is a relationship between you and me. What is that? Student and faculty of Vidhyaashram, right? The same thing you cannot go and ask to some other college, right? Some other college faculty, why do they give you the data, right? Similarly, it provides the request and relationship based on the connection. We should have request and response, both are connected, then we can do something on the database. So as we know, abstraction we are achieving, we have to design an architecture such that we have to achieve the data abstraction. Database architecture can be seen as in a single tier or the multi-tier. Single tier or multi-tier. In multi-tier again we come across with the 2-tier and then the 3-tier architecture. So basically we are trying to say you that there are 3 types of architecture in the database management system. One is single tier, that is called as 1-tier architecture, and in multi-tier we have 2-tier architecture and 3-tier architecture. That's what is depicted in the picture. Database architecture has been categorized into 3 types. One is 1-tier architecture, 2-tier architecture and then the 3-tier architecture. Let's see one by one. What is 1-tier architecture? 1-tier architecture, here you can see 1-tier architecture, the client directly deals with the database. There is no intermediation between the database and then the client. That is a single transactions. what we have? Here we have a client, here we have a database. Fine. Client is directly communicating, sending the request to the database, and database is giving the response directly to the client. Request response. Okay. There is no intermediation between the client and then the database. Whenever we are accessing, works directly with the database. Okay. What is the problem in this? When we are working directly with the database, that is physical data present in the database, there is, if any changes made by the client, that will affect the complete database. So, most of the time, user is not allowed to have a direct communication with the database. Who can do the direct communication with the database? Database administrator is there. So, just we have seen that who is the database administrator and what are the job he can do. So, when we are doing this one-tier architecture, most of the time administrators use this one-tier architecture. So, next what we have is two-tier architecture. Here you can see in the two-tier architecture, we have a database here, we have a user or client here. Right. So, how client is communicating with the database? By using one application interface, that is called as user application interface or client application interface. Client is not communicating directly with the database, but there is one application system developed by the database design, and that is called as client application. User sends a request to the application, then through the application the request is gone to the database. So what we are doing here, we are providing the abstraction, data abstraction. Direct communication is not there. So using the application, the communication with the database has been established. So to overcome from the disadvantage of one tier, we are using the two-tier architecture. Here you can say user interface and the application program run on the client side. One application program will be there which is on the client side. User interact or interface with that application program. At the server side, the response to provide the functionalities like query processing and then the transaction processing. What this application will do? Application takes the request from the user, that will be processed in the form of query or in the form of transaction, and that query has been sent to the database. To communicate with the database, client-side application establishes a connection with the server side. So, we are not establishing the connection directly with the user. Client-side application establish the connection between the database system. So, this is about two-tier architecture. When we come to the three-tier architecture, there in the two-tier we have only client application. Here we have a server application too. Client is not directly communicating with the server. Client is communicating with the application server, from application server then to the database. User sends a request to the client application where the request is converted in the form of queries. This queries is sent to the application server where the server decode that queries and send it to the database, from responding back in the same manner. From database to application server, from application server to the application client, from application client to the user. Then in the three-tier architecture contains another layer between the client and server. In this architecture, client cannot directly communicate with the server. Client is not directly communicating with the server. The application on the client end interacts with the application server, which further communicate with the database system. End user has no idea about the existence of the database behind the application server. User, what he'll think? This is my end point. User will think application server is an endpoint. From here, the data is transferred to the user. No, but user has no idea there is a database behind the application server. From that database, application server is fetching the data. So that is the advantage. Here we are providing one more level of abstraction. Client does not know only how the database and where the database is. The three-tier architecture is used in the case of large web application. Where we are using three-tier architecture? When we are developing a web application. Once you want to develop any website, you need not to know the basic level of your company. What you have designed, that will be seen by the user. So that is when we are designing the web application, the three-tier architecture will be used. Next, what we have is data independence. What you mean by data independence? Data independence can be explained by using a three schema architecture. We have already discussed three schema architecture in the session 2. Data independence refers to characters of being able to modify the schema at once. As we have three schema architecture, external, conceptual and internal. Whenever some changes has been done to the internal schema, that should not affect the conceptual schema. If any changes has been done on the conceptual schema, that should not affect on the external schema. That is a data independence. Data is independent of itself. It's not dependent on any of the schema. There are two types of data independentness. One is physical data independentness. That is logical data independentness. Logical data independentness is what? Whenever any changes is done on the conceptual logical level, that should not affect on the external level. The logical data independent is used to separate the external level from the conceptual level. So this is a external level what you have. This is a logical or conceptual level what you have. So and this is a internal level what you have. Okay, any changes made in logical level should not affect on the external level. That is what the logical data independentness. Okay, that is what logical data independentness. If we do any changes in the conceptual view of the data, then the user view of the data would not be affected. Okay, that's what explained. Next, we have physical data independentness. What do you mean by physical data independence? Any changes made to the physical level of the data should not affect the logical level, should not affect the conceptual level. That is a physical data independence. If we do any changes in the storage size of the database system server, then the conceptual structure of the database will not be affected. That is called as physical data independentness. So that is what depicted here. This is external level, logical level and physical level. This is stored data. Any changes made in the physical level, that should not affect on the logical level. Any changes made in the logical level should not affect on the external level. Logical data independence is done here and the physical data independence is done at this level. Next, we move on to database languages. So, how many languages are there and what all these languages are? Database management system have the appropriate language and interface to express the data queries and updates. So, how we have to ask, how we have to request, how we have to do request and then the response is by using some type of languages. When we are dealing with the database, such type of languages is called querying languages. We are questioning. Request is in the form of question. That is called as querying. So, let us see what all the different types of database languages we have. First, we have is data definition language. That is called as DDL, data definition language. Stand for data definition language, used to define the database structure or the pattern. Why we are using? As name itself indicate, we are defining. To define a database, we are going to use this particular language. It uses to create the schema, table, index and then the constraints. Why we are using definition language? To create the database, means to define the database. Okay, using DDL statements, you can create the skeleton of database. how database has to be, that will be defined by definition language. It is used to store the information of metadata. Already told you what is metadata. So, to store the information of metadata, we are using the database definition language. Now, let us see what all the operations we can do using the DGL. That is creation. We can create the database, create the object in the database. Alter, if after creating, if I want to alter any database, we can use the alter command to do the alter operation. Drop, if I created one table, I don't want to use that table for the further database, I can drop that table, I can delete that table, that is drop table. Truncate, it is used to remove all the record from the table. Drop is what? To delete complete object, and truncate is what? To delete one record in that particular table. Rename, if I have given the database name or the table name as a student, I want to rename it as student 1, 2, 3. I can do the same. Rename, it is used to rename the object. Object is nothing but we are referring to the table. Comment, it is used to comment on the data directory. What type of data we are using? We can use to comment, to make understand easily, we are using the comment. And these commands are used to update the database schema. That's why they come under the data definition languages. What all we are doing? In all these operations, we are defining the data. So, it is called as data definition language. Next, what we have is data manipulation language. Manipulation means changing. What we have to change? The data within the table. Data is created using the table, that is data definition language. It gives the structure. In that structure, we have to insert the values. So, that has been done by manipulation. So, DML, that is stands for data manipulation language. It is used to access and manipulating the data in the database. It handles user request. Whenever user request for something, or user want to insert, or user want to delete anything, that can be handled by manipulation language. So, see, these are some of the operations that can taken care by the data manipulation language. That is select. If I want to select only one column of the table, that can be done by the manipulation language. If I want to insert a new value or the new record or new row into the database, that can be done using the insert operation. Update, any updation. If I have already created one database, I want to update with one more column, that can be done using the update operation. And delete, deleting one record from the database, from that particular table, that is called as delete operation. Next, what we have is third type of language, that is data control language. In that is called as DCL, stands for data control language. It is used to retrieve and store or saved data. When we want to retrieve the data, we are using the data control languages. And DCL executes a transaction. It also has rollback parameter. It can roll back. It's just like doing undo, reversing. Whatever you have done, reverse it. That option is given in the data control language, because it's controlling all the data of the database. Next, what we have is transaction control language. What all the operation we can do on the data control language is grant the permission, revoke, remove the permission. Like, there are the following operations that have authorization of revoking or taking out of the permission is called as that all comes under the data control language. Those are connect, insert, usage, execute, delete, update, and then the select. These are all the operations that can be used by data control language. Fourth type of language what we have is transaction control language, called as TCL, stands for transaction control language, used to run and changes made by the DML statement. Using manipulation language, what all the changes has been done, that will be controlled by the transaction control language. Here are some of the tasks that can come under TCL, that is commit and then rollback, undoing and then doing. Both will come under transaction control, requesting and responding. Interface in the database. What do you mean by interface? Interface is that is how the database provide the interaction between each other. That is what as interface here we are referred to. Database management system interface is a user interface that allows for the ability to input the query to the database without using any querying language. Without using any querying language, how we can communicate with the database? There are different types how we can communicate. We will see one by one. So in the interface, first we have is menu based interface. What do you mean by menu based interface? When you go to any website, you will be having some menus there, like clicking on that particular button, it will display the menu, like for file, open, save as. These are all called as menu. That is menu based interface. Using the menu, you can insert some data into the database. That is called as menu based interface for web client and browser, where we are using it for web development, and in the browsing most of the time we used a web menu based interface. Next type of interface what we have is form based interface. Form based interface, you are inserting the values, you are inserting the data into the database in the form of forms. You might have seen when you are playing something or doing anything on the mobile browsing, there one form will come saying that please do, we are doing some survey, please do fill the form that will help us, so on, like that. So that is form based interface. If you enter, the details will be stored in their database. So that is form based interface. Example, SQL forms is a form based languages that specify the queries using a form of design. That is not using the queries but using the form based designs, we are inserting the data here. Next, what we as graphical user interface. Most of you know what is graphical user interface, GUI. By using drag and drop option, you can insert the data into the database. That is, the user then can specify a query by manipulating the diagram. By manipulating the diagram, how you manipulate the diagram? By inbuilt functionalities, that is drag and drop. To use what we are using, the most GUI used pointing device as mouse. When you click on, it will display, you can add the data into it. When you close it, it will close, data will be saved in the database. That is most frequently used GUI is mouse, to pick the certain part of the displayed schema from the diagram. We'll drag that and will drop some other diagram into that part. That is GUI interface. Next, what we have is natural language interface. What do you mean by natural language interface? These interface accept the request written in English or some other language and attempts to understand them. Now, you can take an example of Google. If you write something in the Google, you are not writing in the form of query, but the data coming for you is from the database. You just write it in the English form or in the Kannada or whichever the language you know, and whichever the language your Google supports, right? That is called as natural language interface. You are fetching the data using the natural languages. So that is what the natural language interface is. Next type of interface is speech input and speech output. Best example, again a Google. If you don't want to type, your soul lethargic to type also, if you speak by holding the mic, it will give you the, it will retrieve the data what you are requested for. That is for speech input and output. It also gives the output in the form of speech. No need to read also, just if you can listen, that's more than enough. Example for that, flight arrival, departure and the bank account informations are allowed speech for input output enabled. When you are sitting and waiting for some flight arrival and flight departure will be announced. That can be done in the train also. So all this is an example of speech based interfaces. Next, what we have is classification of database. How many type we can classify the database management system? Database management system can be classified into different categories based on the several criteria, such as we have 3 different criteria. In 3 different criteria, we have different types of database management system. The first criteria is based on the data model. Data model, what we have discussed already. Based on that, the database has been categorized into hierarchical model and then the network model and relational model. How many types we have in the data model? Hierarchical model, network model and relational model. We can categorize the database in 3 categories. Next, classification of database based on the number of users. How many users using the particular database, depends on that we can classify the database. Depends on that we have 2 types of database. One is single user system and then the multi-user system. Single user system, you have your private database, you are the person only using it, that is single person user or single user system. And multi-user system, online book database is multi-user system. Anything that you do online is a multi-user, because you are not only restricting the database for yourself, it is distributed. You are sharing the data with many others, that is called as multi-user. Many users are using the same database at the same point in time is called as multi-user database management system. And then classification of the database based on number of sites, means how many sites we have. Number of sites means where all database has been put, that is called as number of sites. So depending on that, again we have 2 types. One is centralized database and one is distributed database. Centralized database means what? You will be having only one database server. Using that only one database server, you are giving a data for many other people, that is centralized. If what is a problem in centralized database management system is that if the centralized server has some problem, all data will be lost. So next, what is next type is distributed database system. In distributed database system, all the data will be distributed among different servers or different systems. Okay, whenever we are having the different server, the same data has been distributed. You can access from different location. That is called as distributed database system. What is the advantage in that? Whatever the disadvantage of centralized is overcome in the distributed. If you lose one system, get crashed also, you won't lose the data. You can access the same data from other system because the same information has been distributed among many. So that is distributed database system. And next what we have is one more type of classification based on the purpose. Why we are using the database? Depending on the purpose also we can categorize the database. In that again we have general purpose and the specific purpose. Database that is created for general purpose or the database that is created for the specific purpose. For example, general based data, you can take Google database is a general purpose database. You ask anything, Google has an answer for that, right? That is general purpose. Specific purpose, if you go to the medical database, medical hospital, they have only the specific database that is related to the medical or that is related to the patient. They don't have all the database, all the peoples of the country database they don't maintain. They maintain only the database of their client or their patients who has visited their hospital or the clinic. So that is a specific purpose based database. Depending on that we have general purpose and the specific purpose database. Thank you.